was like, I know he still doesn't know this, but it's like Tom Landry perfected this play with what team?
No idea. I don't know the strategy.
Dolphins?
I know.
The shovel pass?
Yeah, and it's like what team? It's like, yeah, Cowboys. There's like for 400, there's a game show and this guy got all 8 wrong. None of the other contestants knew any of the football. They're real easy.
That's because usually if you're smart, you're not wasting time watching football.
You're not actually smart to
No, like
Very intelligent people watching it.
No.
memorize.
I mean, Bryce, like sports, he's
and
a
read a lot.
Nah.
brilliant person.
That usually results in having a lot of
But he
knowledge.
wastes the
Wouldn't
ball
you
with
agree with that?
Bryce
Like,
baseball
I enjoy
bats.
sports, I love sports, I watch sports, but I also realize that if I'm doing that, I'm probably not getting smarter.
Well, you're learning just different stuff.
Yeah, well, I'm learning sports facts.
Yeah.
So was anything on Jeopardy useful facts? In
Some
1927 in Scandinavia, who... It's like the most nitpicky
Wanda.
random
Sure,
stuff
I
that-
agree,
Maximoff.
but,
I don't get how
yeah.
Well educated.
That was Marvel.
So what do we talked about? Quick
Is
review.
wrong.
Andy, equilibrium.
When the rate of forward reaction and the reverse reaction are
Okay, another way to say it. No, absolutely not. You're dead to me. I can't believe you said that. That was like the cardinal sin of equilibrium. What did she say wrong?
It is not said the same.
Where did she go away?
She has to get hydrated.
She just wanted to say some Hail Marys. She committed the cardinal sin of
Oh,
chemistry.
gotcha.
Wait, that's also helpful.
Okay.
Oh.
Well, what did she say wrong? Come on.
She said the
It's
same.
the same. She means it's not changing.
Constant, not changing. Okay.
It's the same with
Then we talked about. Oh, he just up and walked out. Did I offend you? Okay.
I say hydration.
What? You offended yourself? What else? Then we talked about equilibrium expressions and equilibrium constants. And what is always true about an equilibrium constant?
Is at the same.
Okay, that's true. That's not what I was looking for.
It's always the same at the same temperature
It's always constant at a constant temperature.
for that reaction.
Okay, but we also then talked about even though the K is always the same number at a certain temperature, the equilibrium concentrations could have an infinite amount of positions.
Yes.
Okay? So basically what that, if you were to restate that, you would say the ratio of your concentrations is always the same, but not always the same numbers give you, or not always are those going to be the same numbers.
Yes.
So you could have a variety of different numbers that give you the same ratio. Okay, then we talked about K and KP. KP is just your constant, your pressure equilibrium constant, and K is your concentration equilibrium constant. And then we talked about, and I derived the equation of how you convert K to KP and back. Yeah. That's when Annie and Rylan got Annie off track, and all sorts of fun stuff like that. Then yesterday, we talked about shifting left, shifting right, and no shift at all, and we related Q to K. Q is just taking concentrations that you're unsure of where you are in the reaction, if you're at equilibrium or not, and comparing it to what the equilibrium constant is, so you would know, okay, I'm going to produce more products to get to equilibrium, or I'm going to produce more reactants to get to equilibrium, or I'm at equilibrium and nothing is going to change. Okay? And we said equilibrium, chemical equilibrium is a dynamic process. What does that mean? Always moving, always changing, just no net effects. So, today, not overly difficult, I don't think. Oh, that's a lot of words for not a lot of work. Let's skip that.
Tetroxide.
We got the lunar lander. For the NASA Apollo mission. Okay? Consider an experiment in which gaseous N2O4 was placed in a flask and allowed to reach equilibrium at a temperature where Kp is 0.133. At equilibrium, the pressure of N2O4 was found to be 2.71 atmospheres. Calculate the equilibrium pressure of NO2. I think you could do this on your own without me teaching you to. Wanna try it?
The soda has stained the wood of that thing.
Thanks, yeah.
Sorry, I just noticed that it's
Yeah.
gross. Kind of gross.
Yeah, I eat like most of my room right now.
Maybe. I don't know.
Scares some people from coming in because it's such a clutter.
Why did Steven sit on a mouse trap?
What?
Steven like sat on a mouse trap.
That's what Jesse's story.
I mean, that's gonna do anything. You sit on a mouse trap, not hurt at all.
No.
The force of your butt is gonna be more on the mouse trap than the mouse trap could do to lift you up and cause it to do anything.
Yeah. Your finger hurts.
It allows it to. Yeah. Okay, why don't you guys try this?
It gets momentum.
Turn on your brains. Turn on your brains. Waiting for what? Me to show you?
It's fine K, the find the broken.
What?
It's fine K, the find
You already got the K.
K.
Well, yeah.
Then
But
you K.
no, why do you need K? Do you want concentrations? What do you want? Does that make sense? Are you kidding, guys? Okay,
I know how to do it. I know how to do it.
My goodness.
I know how to do it.
This is the best of the best? Holy cow!
No, I've never said that.
That's our psychology.
I've always put
What did
myself
you say?
forward.
So that's our psychology class. That's what I did, Mr. Weatherly.
That's
You guys like take the cross.
I mean, technically,
Randy.
I mean,
Randy.
our cream must be pretty watered down.
Towards
Sorry, I don't mean to.
No, it's just spoiled.
We are sour cream.
Probably.
We are cottage
Spoiled.
cheese.
Yeah. I know you guys are smart. That's why it's frustrating when you look at me like a deer in the headlights. It's like, I don't want to do this.
I figured it out.
You don't want to read? You know, ignore this. In fact, ignore everything before this to reach equilibrium. That's all you need after that. In fact, I just read it.
Oh, so literally it gives you, wow, this is actually.
It's literally plug and chug 8th grade math.
Hold.
It's 0.113 equals x over 2.71, right?
Don't say that.
Am I wrong?
But I know too.
I wasn't really listening.
Don't say it again.
Don't say it. You weren't even trying.
Oh, you're supposed
Thank you for giving it an attempt now.
I got it.
You got an answer?
to. Is it different? I didn't do it.
You just square root of that.
Yes, Grant. Yes.
Good job.
You are the cream of the crop, bud.
Is it that?
No.
What'd you get?
You got it wrong.
Close.
Oh, sweet. I didn't do that.
I did it wrong, right?
Yep,
Wrong.
you did.
Well,
Because I thought you, if it's on volume, you multiply
Two.
it, but then it's
Ah.
squares.
Wouldn't you square root it?
So you squared. You're not. If you were solving for NO2, you know NO2, don't you? No, wait, you are solving for NO2. Yep, you are gonna have to square.
Yeah, so I did that.
So you're gonna take. You know this this number, right? Multiply it, square root.
Oh, I squared it, so it's good.
That's what I did. It multiplies the square root of it. What did I do wrong?
You did it.
Point
point-
six.
Yep.
Yeah, 0.6 is what I have. You should have rounded.
Well, his was actually.
Mine's
But it's
0.55.
.600. So that's
Oh.
something you did. You must have plugged in a number that's different than what you should have.
0.113.
Point one. Nope. No. .133.
That's the difference. Times.
Now do you know why I kind of get a little frustrated?
No.
Why?
Yeah, found it.
Get frustrated?
When I ask you to do a problem that I know you know how to do, and you look at me like you have no idea.
That's too many words.
Is it not
Do it
on the
fast.
You want to do it faster? I feel like if you just start doing it right away, that would be the fastest way to do it.
Well, not if you did it right away.
That times that. Square root of
But-
6.x.
There's more benefit to having you do it than to have me
So it's
show it all.
square root of.
Did you guys, Griffins, did you guys figure it out?
Yeah.
And did you get .6? I will show you the next one. It's a little bit more difficult.
1.133.
Oh, now I have to
Just
do it by
convert it to
ourselves.
grams.
All right, do it by yourself.
You just get word.
Emily, why?
What?
This is our last problem.
This one? Yeah, this is it. Once you're done with this, we're done.
You should just try.
I feel like I should probably do something though, because that
No,
video
that's all right.
camera isn't gonna do anything. You guys can see anything.
Has anyone watched one of those two?
I
Yeah,
watched a couple
I
of
have.
them.
I watch.
And I watched one when I was sick.
Grant, what are you saying? What I'm doing
You
is
don't watch
pointless?
it.
I've been here every day.
I watched the one
Yeah.
where
Yeah,
That's what I'm saying, no
Yeah.
one's here.
I
No one's
missed
gone.
it.
Yeah, I watched
Cool.
like
Or so.
at the very beginning. I watched a couple just to refresh myself. before I did it.
But
I
honestly,
had to get out.
the videotapes are not so much for you as they are for next year.
When you sick.
Like if I'm gone, if I'm sick, I can just throw my video out. Student teacher, or not student teacher, sub teacher. Or if you're gone, I will have them already uploaded to school. You just, watch it then. If I could get them uploaded and on a Schoology that day, then it would be, more beneficial.
Take forever.
But it takes a long time to upload, and then I got transferred to Schoology. And this was a little bit harder.
Of all species in the value of K.
So, you have enough information. Well, first, you're gonna have to write your equilibrium expression. Then you're gonna have to find your equilibrium concentrations. Once you find your equilibrium concentrations, you can find your K.
So you divided by 0.5 or 1?
1.5.
Because it's 1 to 1.
Just one, yep. 1. So essentially, your moles are your molarity,
Yeah. Okay.
but that's not
So those are
your,
your concentrations?
but not your equilibrium concentrations.
Oh, it's fine.
But none of them.
One of them is your equilibrium concentration. The other two are
So you
not.
find the ratio and then.
Well, I could set up. This is the introduction to the ice table.
Just do it.
I'll just do it. I'm going to give myself a little bit more space. And I'm actually going to, I didn't plan on doing this, but I'm gonna do it anyways. I'm actually gonna set it up like what our ice tables are gonna look like, tomorrow. Well, yeah, I can do that. Yeah, Monday. So, you guys get your equilibrium expression all written out? Okay. All right, then, here's what really the ice table is. So I'm just gonna do this to kind of set we'll be doing this idea for the next 2 months. Applying this to a variety of things, starting with what we're doing here, going all the way through all acid-base equilibrium, okay? So what I'm going to do is I'm going to put then what is my initial concentrations of these guys? PCl5, what is it? Just divided by 1.
Yeah.
8.747
Okay, how about PCl3?
0.298.
No, that's equilibrium. The initial concentration is 0. So this is the equilibrium concentration. So, now what I want you to notice, so technically I have the equilibrium concentration of this, which was 2 times 10 to the negative 3. That should tell me my change. Now let me show you, everything is a 1-to-1 ratio here, correct? And as this progresses, we know we went from 0 of this to an amount of this at equilibrium, which means from where I started to where I got to at equilibrium, which way did it shift to get to equilibrium? To the right, okay? Which means I'm increasing in this, and I'm losing that.
It just the answer CL2 would start with 0. Is what you're changing, it just.
Yes. Now, this is actually easier than what we're going to do in the future because they won't give us this, and we'll actually have to take the changes, plug them into the equilibrium expression, and solve for x. So this isn't quite as difficult as what it will be in the starting next week, okay? Because they won't give you this, and they'll just give you initial, and you'll have to figure out what the change is, plug the x's into your equation, solve for x, and then go back and figure out what your equilibrium concentrations are. Okay? But since I know that this is my change, essentially, I could say that to get my equilibrium concentration, it would be my initial minus my change, right? Does that make sense, since everything is a 1-to-1 ratio? If, to get to equilibrium, I gain this much, since these are 1-to-1 ratios, I'm going to gain that same amount. And since this is a 1-to-1 ratio, I'm going to lose that same amount. Does that idea make sense?
Yes.
If this was a 2, then this would be 2 times the change. If this was a 3, this would be 3 times the change. That make sense?
Yeah.
Okay, that's what we're getting to. Now I know that's not what it is in this case, so I'm going to get rid of them. So essentially, it's initial minus my change, which we said was that, and this plus my change because I'm shifting right, so I'm producing products. I don't have enough space. What we get is an equilibrium concentration of my PCl3 of 0.3. If I take 0.002 and add it to 0.298, you get 0.3. Okay, this is going to go down. We already knew this was the equilibrium concentration of Cl2. So now what I have is all my equilibrium concentrations, which that was part of what it asked us to do. It wanted us to find the equilibrium concentrations of all species. And then it wants us to what? Find K. 0.09. Sure. I would go.
It's the only way it's around.
Figs.
Well, it's 0.08955. So it's gonna.
8.96 times 10 to the negative second.
Okay, sure.
So what tomorrow will bring, not tomorrow, why do I keep saying tomorrow? What Monday will bring, will be doing this idea without knowing one of the equilibrium concentrations, where you'll have to take your initial concentrations, find your change, and these aren't always going to be 1-to-1 ratios. In fact, tomorrow we'll do ones that aren't. We'll plug them into the equilibrium expression, we'll solve for x, and x, since x is the change, we can take our initial along with our change to find what the equilibrium concentrations are. Now, it becomes significantly more difficult when you have a coefficient here, because not only does that make this negative 2x, but it also takes and makes this squared. So it's really negative 4x to the second. And when you get into things that have a coefficient of 3, that's when you start dealing with, your cubed root stuff. You might see some quadratic formula, quadratic equation stuff some of the next week. Remember the fun quadratic equation?
Yeah.
We will do that. All right? We're done.
And they're good at math.
This year?
This is my only math-ish class this year.
Well, good thing you'll get a decent amount of math in this class.
I've done it since third quarter last year.
Class.
I had algebra 2, so.
You took algebra 2 last year?
Quadratic stuff was, yeah. I took algebra 1 as a eighth grader.
Makes sense.
I was thinking-
Are you gonna take a math class next year?
Just take physics. Probably just physics. I don't really want to pursue pre-calc, so.
Pursue.